Alright, so this is the second part of our video series on graphing inequalities in two variables. In this particular video, we're talking about systems of inequalities. So, the following is a system of inequalities in two variables. This is an example, okay? I mean, obviously there's lots of different systems out there. Here's one for you to look at. The solution to a system of linear inequalities is an ordered pair that makes all the inequalities in your system come out to be true statements, okay? So, typically, like for this one, you have two inequalities and two variables, x and y. What we would be looking for are all the x's and all the y's that make both inequalities come out to be a true statement. Essentially what we're going to do, and you can kind of read all this here. So we're going to read all this on your own, it's in your notepad. But what it's saying is that when we graph this, we're going to graph both inequalities in our coordinate plane. We're going to still have our boundary lines solid or dotted like we saw in the previous video. And we're still going to shade just like we did in the previous video by finding a test point. What we're looking for now, though, since we have systems, are where are the overlaps? Because the overlap is where the x and the y's are going to solve all of these inequalities in our system. Okay, so let's do an example. Okay, so we want to graph the system y is greater than or equal to negative 3x minus 1 and y is less than x plus 2. Alright, so what I want to do is first sketch my coordinate plane. And again, it's just a sketch, so my left and right axis is my x, my up and down axis is my y, and let's just call it 6 units on each side. 2, 3, 4, 5, 6, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 2, 3, 4, 5, 6. Okay, so now we actually have it pretty easy. I'm going to do the top inequality in red, the bottom inequality in blue. But what we want to do now, since we have our y's are by themselves. Anytime you have y by itself, you can use your calculator to kind of help you along. If y is not by itself, do a little bit of scratch work algebra on your own paper and get y by itself. That way you can use the calculator like I'm about to kind of help me out and get me going. So I'm just going to take care of the red inequality first. I'm going to use my inequality, or use my calculator. Again, y is by itself here, so what I want to do is graph that inequality. So I'm going to go to y equals, clear out all the ink that's already there. Go to y equals, and I'm just going to type it in. So y equals negative 3x minus 1. Graph. Now I know that this top inequality, which I'm doing in red, is going to look something like that. That's what the boundary line is going to look like. So that helps right there on its own. It tells me what the boundary line looks like. But I don't even know exactly where that boundary line needs to be. So I'm going to go to my table. And I'm going to just pick some nice points. All you really need, since it's a straight line, is going to be 2 points. Obviously, the more points you put in there, the better. I'm just going to do 2 just to try to save a little bit of time. So my first point that I want to have is 0, negative 1. So right here. And then 1, negative 4. So 1, negative 4. 1, 2, 3, 4. Okay, now, before I just draw a line, I need to figure out what type of boundary line do I need. So I'm going to look at my inequality symbol. I notice that there's a line under it, so that means I need a solid boundary line. So I'm going to do the best I can to connect these dots. Okay, that wasn't very good, but it's going to be close enough for our purposes. Obviously, if you had like a straight edge or something, a ruler, or just even the side of a credit card or something, you could draw a straight line a lot better than me. What we want to do now, though, is pick a test point. Again, it doesn't matter what test point you use, as long as that test point does not live on your boundary line. Well, for this particular inequality, the red one, the point 0, 0 does not live on the boundary line, so I can use it as a test point. So that's what I'm going to do. First number is always your x, second number is always your y. So I'm going to go to my red inequality and do a little bit of scratch work. Everywhere I see an x, I'm going to put in a 0. Everywhere I see a y, I'm going to put in a 0. And if it comes out to be a true inequality, then I'm going to shade on the same side where 0, 0 is. So on the right side of this line. If 0, 0 does not make the inequality true, then that implies that everything on the left-hand side will work. Okay, so let's do our scratch work. So 0 greater than or equal to -3 times 0 minus 1. Okay, let's clean it up. 0 greater than or equal to 0 minus 1, and 0 is greater than or equal to -1. 0 is bigger than or equal to -1. That's true. That makes sense. So that means everything on this side of the boundary line is also going to be true. And I'm just going to roughly shade it. Okay, so that means that's where the top inequality by itself works. Okay, so I'm done temporarily with the top inequality. I'll erase my scratch work. Now what I want to do is look at the bottom inequality only. I'm going to start the process over. I'm going to, since y is by itself for the bottom inequality, I'm going to use my calculator to kind of assist a little bit. Okay, so I'm going to go to y equals, clear out everything that's there, and I have x plus 2. I want to go to the graph. Now I want to pick some points, or go to the graph. That's what the boundary line is going to look like. It's going to be a line that goes from the bottom up in a diagonal fashion. Now I want to go to my table and find a couple of points. Remember, since it's a straight line, you need at least 2 points. If you want to put more points, that's fine. It's your business. I'm only going to use 2 though. So the first point I'm going to pick is 0, 2. So right here, and the other point I'm going to pick is -1, positive 1. So that point right there. Okay. So now before I start drawing a line, I want to figure out what type of line do I need for my boundary. Based on the inequality symbol, there's no line under it, so this line should be dotted. So I'm going to draw a dotted line just as best as I can, straight line, something like that. And now again, I want to find a test point that does not live on this blue boundary line. Again, all I'm looking at is the blue right now. 0, 0, again, does not live on the boundary line, so I can use it as a test point. I'm going to. If you want to pick a different test point, that's fine. Just make sure it does not live on this boundary line. So again, scratch work for my blue bottom inequality. Everywhere I see an x, I'm going to put in a 0. Everywhere I see a y, I'm going to put in a 0. So I have 0 less than 0 plus 2. Now let's simplify and clean this up. So 0 is less than 2. 0 less than 2 is a true statement. So since 0, 0 was this point and it worked and it's below my blue boundary line, that implies that everything else below my blue boundary line will also work. So I'm just going to shade. Okay, now we want to find all of the x's and y's where both inequalities work at the exact same time. So what I'm looking for now is the overlap. So my overlap is this region right here in green, where both the red and blue inequalities work at the exact same time. So again, it's just a rough sketch. Obviously, you know, when we first started this class, I told you might want to get you some colored pencils. This is one of the major reasons why. Obviously, if you're using lots of colors, it's easier to see. If you're doing everything with just a regular pencil, black and white, it could get a little confusing. So, that's it. Okay, and that's it for this video. Again, you cannot do this in your calculator, so this is one of the things where you have to be able to do it pencil and paper. Okay, so practice.